Hello, this is Professor White, and today we will talk about functions, primarily operations and compositions, and finding the inverse. So let's get started. I'm going to structure it this way. I'm going to take functions, add them, subtract them, multiply them, and their domain and range work kind of together for those three operations. And then we're going to divide two different functions. And that's the domain and range. They're going to modify a little bit. You'll see how that works. And then compositions, that means how do you take a function and you kind of compose it. Take the function of that first function. That kind of introduces the concept of inverse functions. And we're going to find out what kind of functions can be taken inverse of, because there might be some special functions. They are not one-to-one. Then you cannot take the inverse. So let's go over all these concepts. So I'm going to do some problems and try to do it practically. Let's say I just got some things done in here. I'll give you adding, subtracting, and multiplying, and dividing. So adding, subtracting. So given this function, f of x is square root of x minus 1, and g of x is 1 over x minus 2. Okay? I'm going to add them first. F of x plus g of x. You can also write them like this. F of f plus g of x. Notation. So what does that give you? That gives you square root of x minus 1 plus 1 over x minus 2. Let's look at the domain of that. Let's look at the domain of f first. What is the domain of f? You can watch the functions themselves video, the video previous to this, and you know that your domain is going to be 1 to infinity, because otherwise you cannot take the square root. And domain of g is everything but 2, because it's in the denominator. Everything but 2. For notations, you can also watch the inequalities video. So when you put the f plus g, what you're going to do is, what is the overlap of these two things? What is that? Okay, I want everything to be positive, 1 to infinity, but I do not want 2. How do I write that? Where they overlap? That's going to be 1 to 2, I do not want 2, and everything bigger than 2. Does that make sense? All right, that's how you do it. How about subtraction? Subtraction is the same exact way, and actually I don't have to write that. I'll do it in red. Let's say I'm looking for the subtraction. All I have to change is this, and this is going to change. Everything is going to be the same. df, dg are the same, and you're subtracting. Your domain will be the same, because this is going to be just a negative, and again, you're going to look at the overlap of those two domains. How about, so I did that with subtraction in red. How about I do multiplication? Let's do that in purple. Multiplication, change everything to multiply. Okay, and what will be the domain? Again, subtraction, addition, because they kind of work together. Overlap, so it's just the multiplication. Well, I have to have, not have 2, but I have to have everything greater than or equal to 1. So the domain is not going to change. Perfect. So the domains kind of work together. But how about the division? Let's look at the division of these two guys. F of x divided by g of x. You can also write that as f over g of x. Okay? what will change? Now the other thing, so you're going to have this thing in here, x minus 1 divided by 1 over x minus 2. What will you get when you do that? X minus 2 times x minus 1. Now, I cannot, when I do this, I cannot have this to be 0. Does that make sense? I cannot have 0 in there. Okay, well, is that possible? It's not possible anyway. Don't look at this version, just look at this version. 1 over x minus 2 is never 0. Okay, so I don't have to worry about it. All I have to worry about this to be real, and all I have to worry about this to be real. And in this particular case, it's, you know, you're going to get the same domain. You're going to get 1 to 2, 2 to infinity. Even though it looks like this at 2, but in here, I can do this flipping unless x is not 2. So I need to take that x out. So be careful of that. So this is putting it together with, you know, different operations. What else do I have? Well, what the heck is the composition of functions? And this is how you show it. Let's say I have an f of x and I have a g of x, and they're both functions. So if I want to do f composite g of x, what that means is this, of g of x. Well, if you kind of look at it as a Venn diagram, this goes first. So in other words, you take an x and you take the g of x. And then you take that g of x as input, and then you go and do f of g of x. Alright, well, let's look at this. Let's assume I have the same f of x and g of f. F of x is rad x minus 1. G of x is 1 over x minus 2. And let's say I want to do f composite g of x. So that means f of g of x. Start with the inside. That means f of, what does g of x do? 1 over x minus 2. Alright? What does f do? F goes, takes this input, and then subtracts 1. So you're going to get 1 over x minus 2 minus 1, which is the same as 1 minus x minus 2 over x minus 2, which is the same as negative x plus 2, so that's going to give me 3 minus x over x minus 2. Does that make sense? Okay. What else do you need? Let's also look at the g of x has to be in the domain of f. Does that make sense? Because you are taking the f. So let's look at another one, composition. So let's say I have an f of x as rad x, and g of x is 2x minus 1. And I want to look at the domains of those guys. So what is f composite g of x? So g of x goes first, and then f goes next. So this is f of 2x minus 1, which is, what does that do? Takes the 2x minus 1. What does that mean? So let's look at the domain of f first. Domain of f is 0 to infinity. What is domain of g? Domain of G is all real numbers because it's just, a line. But what is domain of F composite G? What does this give me? This has to be positive, right? 2x minus 1 has to be greater than equal to 0. So that means x has to be greater than equal to 1/2. Even though this is like this, not that straightforward, you have to kind of look at what this does and see how the domain and range works. So in other words, this domain is going to be 1/2 to infinity. Does that make sense? Okay. If you do the other one, let's say G composite F of x. So that's going to be G of F of x. What does F do? F does square root. What does G do? G goes, multiplies by 2 and subtracts 1. Okay? What will be the domain of G composite F? That's going to be domain of this. What is it that you cannot, put in? It has to be 0 to infinity. All right? So pay attention to that. So when you go and do problems, make sure that you look at your final function and kind of write down the domain looking at that. Let's see. All right. Now, I was going to cover one-to-one functions. I write it like this, one-to-one function. Or one-to-one function. That's a function that looks like this. One thing goes to one thing. You start with the domain. Everything in the domain only goes to one thing. So this thing is a one-to-one function. This thing is not even a function, so it's not a one-to-one function. How about this one? This one is not either. One thing has to go to one thing, one-to-one function. So you can look at the Venn diagrams. Is this a one-to-one function? Of course. One thing goes to two things. That's not good. All right? That's not even a function. Skip it. How about this one? Two things goes to one thing. That's something like x squared. That's a function, all right? But it's not a one-to-one function. Okay? So let's scroll this up so that you understand the one-to-one functions. So another way of checking one-to-one functions is algebraically. And let's say somebody gives you something like this. F of x equals 2x plus 1 over x minus 3. So you may end up doing a lot of algebra in there. You are looking at, if you're taking x1, not x2, and you look at whether or not that will generate f of x1 different than f of x2. So you will just go ahead and start with equating them and see if you get a contradiction. So you do this. And you say, well, is that this guy? And you cross multiply this with that. And now you're going to get this. And now you open this up. And you open that one up. This left is going to be equal to the right, if x2 equals x1. But I don't want x2 to be x1. So if x2 is not x1, f of x1 is not x2, f of x2. Alright, so the only way that can happen is this. That means f of x is 1-to-1. This is how you check one-to-oneness. Assume they're equal and see if you have a contradiction or not. Alright, now if a function is is 1-to-1, I said you can take the inverse. What does that mean? And this is how you write it. Let's say f of x is given 2x plus 1, and that's a line. I know it's 1-to-1. So what this does is you start with an x, and then every x will go to 2x plus 1. This is your f. So if we're talking about inverse of f, and this is how you show it, f inverse of x. Don't put that -1 above the x. So in other words, you take this, you take the inverse of that. So in other words, f inverse of f of x, you end up with where you started. So here's the definition. F inverse of f of x is x. The same token, f of f inverse of x is x. Somebody asks you, is this function inverse of the other function? You just have to check that. If that doesn't work either way, then it isn't. So the other thing is, let's look at this. Let's say they're asking me to find the inverse of this guy. What is its inverse? Alright, this is how you do it. You just go and instead of f of x, you write y. And then you reverse x and y. Then you solve for y. Then you replace the y with f inverse notation. So f inverse of x is simply equal to x over 2. Well, check whether or not we did this right. So let's go and let's check f of f inverse of x. This is to check. So let's start with f inverse. F inverse is x over 2. What does f do? It takes it, multiplies by 2. And when you multiply x over 2 by 2, you get x. Oh, beautiful. So in other words, x over 2 is the inverse of 2x. Well, how do they look like, those guys? X over 2, I want to draw 2x, and I want to draw 1/2 x, which is its inverse. 2x, 2 over 1. So this is kind of a steep slope, 2-to-1 slope. And the other one is the other way, 1-to-2 slope. So you go up 1 and then you go 2 over. So 1-to-2 slope. Okay? Now people kind of looked at those functions and inverses, and it turned out that they're always symmetric with respect to y equals x. And this is how I explain this in my class. And I like flowers, so I always draw a flower. Let's say you have some flower or something. Just think of it. And when you want to put a mirror in here and draw its inverse of that flower, it's going to look like this. Does that make sense? I mean, this is obviously not a function, but conceptually, that's what's going on. The inverse of a function is going to be always reflected along y equals x. Thank you for watching.